Let's begin. At the very start of a star's life, not in fire or light, but in darkness, in the cold, quiet spaces between the stars. Here, in these vast, mysterious regions of space, lie nebulae. Massive clouds of gas and dust, stretching across light years, floating gently in the darkness. To the human eye, many of these clouds are invisible, but through telescopes tuned to the right wavelengths, they glow softly. Pink, purple, blue, like cosmic watercolor paintings on the canvas of the night sky. These nebulae are more than just clouds. They are the cradles of stars. They are stellar nurseries where new stars are born. But how does something as enormous and formless as a cloud of gas become something as dense and fiery as a star? It begins with gravity. Even in these quiet clouds, there are tiny irregularities. Regions where the gas is just a little denser, a little colder, and over time, gravity begins to pull more and more material into these regions. It's a slow, patient process, thousands, millions of years. These clouds drift, collide, swirl. Shockwaves from nearby supernovae or colliding galaxies might jostle the cloud, triggering regions to collapse more rapidly. As the gas collapses, it forms clumps, protostars, hidden deep inside the cloud. At this stage, the protostar is still shrouded in gas and dust, invisible to optical telescopes. But inside, pressure and temperature are building. The cloud collapses more. The material at the center grows hotter, denser, compressed by the relentless pull of gravity. This is a delicate balance. If the collapsing clump gathers enough mass, the temperature in its core will eventually reach millions of degrees Celsius. And when that threshold is crossed, a profound transformation happens. Nuclear fusion ignites. Hydrogen atoms begin to smash together, fusing into helium. This releases an immense amount of energy, light, heat, radiation, pushing outward against the inward pull of gravity. At that moment, the star is born. It emerges from its cocoon of gas and dust, shining for the first time. This is the beginning of its life as a main sequence star, a phase that, for many stars, lasts billions of years. But even in this new stage, the balance continues. Gravity tries to pull the star inward. Fusion pushes outward, holding it up. This fragile balance will define the star's life, and eventually, its death. But for now, the star is young. It burns steadily, quietly, a newborn beacon in the darkness. Some stars will form alone, others in clusters of thousands, siblings born from the same cloud. And as they begin their long, luminous journey across time, the next chapter of their life begins. In the next section, we'll explore this main sequence stage, the long, stable, yet slowly changing phase that defines most of a star's existence. When a star ignites nuclear fusion in its core, it enters what we call the main sequence phase. This is the longest chapter in a star's life. It's a time of balance, of stability, of quiet power. For our Sun, this phase has lasted about 4.6 billion years already, and it still has about 5 billion more to go. But let's step back and see why this phase is so important, and what exactly is happening inside a star during this time. Fusion, the engine of the stars. At the heart of a main sequence star, an extraordinary process takes place: nuclear fusion. In the intense heat and pressure of the core, temperatures around 15 million degrees Celsius, hydrogen atoms collide at such speeds that they fuse together, forming helium nuclei. This fusion releases vast amounts of energy, not in explosions, but in a steady, controlled burn. This energy radiates outward, traveling slowly, sometimes taking thousands of years to reach the star's surface. It's this outward pressure from fusion that holds back gravity. Remember, gravity is always trying to pull the star inward, trying to collapse it. But as long as fusion continues in the core, it pushes outward with equal strength, maintaining a delicate hydrostatic equilibrium. This is why stars are stable for so long. They are not violent, they are not chaotic, they are perfectly balanced systems. But this balance depends entirely on the star's fuel, hydrogen, and this is where the star's mass becomes its destiny. The mass factor. Small stars versus massive giants. Stars come in many sizes. Small red dwarfs, the most common type of star in the universe, burn their fuel incredibly slowly. Some may live for trillions of years. Medium stars, like our Sun, live for billions of years, slowly growing hotter and brighter over time. And massive stars, many times the mass of the Sun, burn furiously, living fast and bright, but dying young in just millions of years. Why the difference? Because the more massive the star, the more pressure it creates in its core. That means faster fusion rates, more energy, more brightness, but also a quicker depletion of its hydrogen fuel. In the case of red dwarfs, their low mass allows them to sip hydrogen gently, staying stable for eons. These small stars may still be shining long after the universe's more massive stars have all died. The changes over time. Even during the main sequence phase, stars are not static. As hydrogen fuses into helium, the core composition changes. This means the core contracts slightly, temperatures rise, and the fusion rate increases. Over time, the star becomes hotter, brighter, and larger. Our Sun, for example, is about 30% brighter today than when it was born. This gradual brightening has had, and will continue to have, significant effects on the planets around it, including Earth. As the star ages, the amount of available hydrogen in the core decreases. Eventually, the star reaches a tipping point. There's no longer enough hydrogen to maintain the balance. The fusion slows. Gravity begins to win again, and this marks the end of the main sequence phase. What comes next is transformation, and for some stars, drama. Because when a star's core starts to run out of fuel, the next stages of its life can become turbulent, beautiful, and even catastrophic. In the next section, we will follow stars as they leave the calm of the main sequence and begin the journey toward their inevitable end. Some will fade gently, others will die in the most spectacular explosions the universe has to offer. Let's explore the death phases of stars, starting with their expansion into red giants. As a star exhausts the hydrogen in its core, the long era of balance comes to an end. For stars similar in size to our Sun, stars with low to medium mass, this transition is both dramatic and beautiful. Let's walk through this gentle yet profound ending phase. The core contracts, the outer layers expand. When the hydrogen fuel in the core is nearly gone, fusion slows down. Gravity, relentless as ever, begins to win the struggle. The core contracts, shrinking under its own weight. But something interesting happens to the star's outer layers. As the core collapses and heats up, a shell of hydrogen around the core ignites in a new round of fusion. This reignited fusion shell produces enormous outward pressure, causing the outer layers of the star to expand dramatically. The star swells into a red giant. It grows hundreds of times larger than its original size. Our own Sun, when it reaches this phase, will expand beyond the orbits of Mercury, Venus, and may even engulf Earth itself. But despite its immense size, a red giant's surface cools, giving it a reddish hue. From a distance, it glows like a giant ember in the night sky. Inside, the core, now mostly helium, continues to contract, reaching new temperatures. If the star is massive enough, helium fusion begins, creating carbon and oxygen in the core, but eventually the fuel runs low again. The star doesn't have enough mass to fuse these heavier elements. At this point, the star reaches a final delicate stage, the creation of a planetary nebula. As fusion ceases in the outer layers, they become unstable. The star can no longer hold onto them. They drift away, gently at first, and then more rapidly pushed outward by powerful stellar winds and radiation. The result is one of the most beautiful sights in the universe, a planetary nebula. These glowing shells of gas expand into space, illuminated by the hot, exposed core at the center. They come in delicate, symmetrical shapes: rings, bubbles, hourglasses, or butterfly-like structures. Despite the name, planetary nebulae have nothing to do with planets. The term comes from early astronomers who thought they resembled the disks of planets through small telescopes. In reality, they are the last breath of dying stars. For tens of thousands of years, these nebulae glow softly. Then, as they expand and thin out, they fade away, merging with the interstellar medium. The white dwarf, the embers of a star. What's left behind is the core of the star, a small, dense object called a white dwarf. Though only about the size of Earth, a white dwarf contains about half the mass of the original star. Its gravity is intense. A teaspoon of white dwarf material would weigh tons on Earth. But despite its density, a white dwarf is a quiet remnant. No more fusion burns inside. It shines purely from leftover heat, slowly cooling over billions of years. White dwarfs are the silent embers of stars like our Sun. And over unimaginable timescales, they too will fade into black dwarfs. Cold, invisible, stellar corpses. But here's the poetic part. In the process of dying, the star has released its inner layers into space, rich with carbon, oxygen, and heavier elements. These elements will drift through the galaxy, eventually becoming part of new stars, planets, and perhaps life. The calcium in your bones, the iron in your blood, the oxygen you breathe. All forged in stars that lived and died billions of years ago. You are quite literally made of stardust. This is the gentle, generous death of sun-like stars. But not all stars die so quietly. In the next section, we'll explore the violent, catastrophic deaths of massive stars, events that shake the universe, create black holes and neutron stars, and scatter the seeds of new life. Let's continue our journey. While stars like our Sun end their lives in a gentle exhalation, the universe's most massive stars die with far more violence. Their deaths are among the most energetic, chaotic, and awe-inspiring events in the cosmos. These titans of the stellar world live fast and die young. Let's carefully step through this dramatic ending where gravity doesn't gently release a star's outer layers, but tears them apart in colossal explosions. The life of massive stars. A fast, furious burn. Massive stars, those more than 8 times the mass of our Sun, have a much more intense existence. They burn through their nuclear fuel at a blistering pace. Their cores are hotter, fusion happens faster, and the outward radiation pressure is enormous. These stars live for just millions of years, a blink on the cosmic timeline. But inside them, something remarkable is happening. Unlike smaller stars that stop at fusing helium into carbon, massive stars continue the chain of fusion. In their cores, fusion creates heavier and heavier elements. Helium fuses into carbon, carbon into oxygen, oxygen into neon, neon into magnesium, magnesium into silicon, and finally, silicon into iron. This process creates an onion-like structure inside the star, with layers of different elements fusing in shells around the core. But this story can only go so far. The iron limit iron is a dead end for fusion. Fusing iron doesn't release energy, it consumes it. This spells doom for the star. Once the core is mostly iron, no new fusion can occur to push outward against gravity. The balance shatters. In a matter of seconds, the core collapses. Imagine a star millions of kilometers across, and its core suddenly shrinking in an instant to the size of a city. Gravity crushes the core with unimaginable force, causing protons and electrons to merge into neutrons. At this point, 2 fates are possible depending on the star's mass. But first, something spectacular happens. The supernova, a star's explosive goodbye. As the core collapses, it creates a shockwave. This shockwave rips through the outer layers of the star, blasting them outward at speeds of thousands of kilometers per second. This explosion is called a supernova. For a brief moment, the dying star can outshine an entire galaxy. Its brilliance visible across millions or even billions of light years. Supernovae are not just violent ends, they are creative acts. In the incredible heat and energy of the explosion, elements heavier than iron, like gold, silver, uranium, are forged. These elements scatter into the cosmos, enriching the universe. In fact, the gold in your jewelry and the iodine in your body were made in such explosions. Without supernovae, the universe would be a far emptier place. Neutron stars and black holes. The remnants of titans. After the outer layers are expelled, what remains is the core remnant. If the star wasn't too massive, the collapsed core becomes a neutron star. A neutron star is one of the strangest objects in the universe. It's only about 20 kilometers across, but it contains more mass than the Sun. It's made entirely of neutrons, packed so tightly that a teaspoon of neutron star material would weigh billions of tons on Earth. These bizarre stars spin rapidly, sometimes hundreds of times per second. They can emit powerful beams of radiation from their poles, appearing to us as pulsars. But if the original star was even more massive, over about 20 to 30 times the mass of the Sun, the core's collapse doesn't stop at a neutron star. Gravity overwhelms even the pressure of neutrons. The core collapses into a black hole, a singularity, a point of infinite density where even light cannot escape. These are the most extreme objects created by stellar death. Invisible, silent, but endlessly powerful. The cosmic recycling machine. The deaths of massive stars may seem tragic, but they are essential. Without these violent ends, the universe wouldn't have the elements needed to build planets, life, or us. Massive stars are nature's engines of creation and destruction. They shine, they die, and they see the next generation of stars and worlds. In the next section, we'll take a step back and reflect on the life cycles of stars as part of the grand cosmic recycling process. We'll see how stars, gas, dust, planets, and life are all connected in an endless cosmic dance. Let's continue. We've followed stars from their birth in dark clouds through their long lives of shining stability to their varied and sometimes violent deaths. But the story of stars doesn't end with their death. In fact, their death is the beginning of something new. Let's explore the profound and beautiful idea that the universe is, at its heart, a cosmic recycling machine. A place where death is not final, but part of a continuous cycle of renewal, creation, and transformation. The enrichment of the universe. When a star dies, whether gently as a white dwarf or violently as a supernova, it returns its elements to space. The clouds of gas and dust expelled during these endings don't simply drift into nothingness. They mix with the interstellar medium, the vast, thin soup of gas, dust, and plasma that fills the spaces between stars. But now, these clouds are different. They're enriched. They no longer contain just hydrogen and helium, the simplest elements born in the Big Bang. They now contain carbon, oxygen, nitrogen, iron, gold, silicon, phosphorus. These are the building blocks of planets, of oceans, of life. This process of enrichment is critical. Without it, the universe would still be a dull place, made mostly of hydrogen and helium. Thanks to stars, the cosmos becomes complex, diverse, and capable of producing life. The seeds of new stars and planets. Over millions of years, the remnants of dead stars collide, cool, and clump together. Gravity, ever patient, begins to pull these enriched materials into new clouds. These clouds collapse once again, giving birth to a new generation of stars. But this time, the gas is richer, and around these new stars, disks of gas and dust form planets, moons, asteroids, comets. Our own solar system formed from such a process. The Sun is a second, or perhaps even third generation star, born from the remnants of stars that lived and died before it. The Earth itself, the ground beneath your feet, was built from the ashes of ancient stars. The water you drink contains hydrogen born in the early universe and oxygen forged in stars that exploded billions of years ago. The calcium in your teeth, the iron in your blood, the phosphorus in your DNA, all made in stars. You are stardust, and so is every living thing on Earth. We are quite literally the descendants of stars. The endless cycle of birth, life, death, and rebirth. This cycle is ongoing. Even now, new stars are being born in nebulae like the Orion Nebula, while others are ending their lives in distant galaxies, their light just now reaching us after traveling for millions of years. It's a cosmic rhythm that has no beginning and no end. Birth, life, death, rebirth. It's one of the most beautiful truths of the universe, that even destruction has a purpose, that even death is creative, and that everything is connected in a vast, intricate web of cause and effect, change and transformation. The star that dies today will in billions of years give birth to planets, oceans, forests, and perhaps life, somewhere in the universe. The universe is not static. It is not empty. It is alive with this endless cycle of recycling and rebirth. And the stars are the engines that drive it. Cosmic perspective. When we look up at the night sky, we're not just seeing distant suns, we're seeing the past, the future, and the ongoing story of the universe. We see the light of stars that lived and died long ago. We see the materials that will one day become new stars, new planets, new forms of life. And we see ourselves, because the atoms in your body are part of this great cosmic dance. You are not separate from the universe. You are part of it. You are a chapter in the ongoing story of stars. In the next and final section, we'll reflect on this grand cycle. We'll zoom out and take a quiet moment to appreciate the elegance, the poetry, and the wonder of stellar life and death. Let's bring our journey to a gentle, thoughtful close. We've traveled far. From the dark clouds of stellar nurseries, to the fiery hearts of stars, to their final transformations into white dwarfs, neutron stars, or black holes. We've seen stars live, shine, age, and die. But perhaps more important than the details of physics and fusion is the deeper story behind these cosmic processes. The story of connection. Because when we look at the life and death of stars, we see more than just isolated objects burning in space. We see a universe of relationships. The stars and us, not separate but interwoven. The atoms that make up your body, the carbon in your cells, the oxygen you breathe, the calcium in your bones. They were all forged in the cores of stars. Billions of years ago, a star lived its life, died in an explosion, scattered its enriched contents into space, and those contents eventually became part of the Earth, and part of you. This is not poetry, it's science. But it is also poetry, because it reminds us that we are not observers of the universe. We are participants in it. We are made of the same stuff as the stars. We live because they lived. We die. And perhaps the atoms in our bodies will someday become part of a star, or a planet, or something else entirely. The cosmic cycle, a meditation on change. Nothing in the universe lasts forever. Not stars, not planets, not even galaxies. Everything is part of a cycle of birth, change, death, and renewal. And though this might seem humbling or even frightening, there is beauty in it, because it means everything is connected through change. When we see a dying star, we are witnessing the seeds of future life. When we look at the night sky, we are seeing stories still unfolding, even if the stars themselves have already died long ago. The universe is a web of moments, a dance of matter and energy, and we are part of that dance. We often feel small when we think about the vastness of the cosmos, but I invite you to see it differently. You are not small, you are exactly the size of the universe you came from. You are a thread in the fabric of space and time, woven from stardust, carrying within you the memory of stars. The gift of perspective. Learning about the life and death of stars is more than just science. It's a way to put our own lives into perspective, to realize that we are not alone in the universe's story. We are a continuation of it. Every breath you take, every moment you experience, is part of the universe reflecting on itself. You listening now, are the universe becoming aware? That's not an exaggeration, that's the most profound truth of all. Stars are not distant, cold objects, they are family. They are our ancestors, and when we look up at the night sky, we are looking at our origins, our story, and perhaps our future. A gentle goodbye. So as we close this gentle journey through the life and death of stars, I invite you to take a moment to feel that connection, to breathe deeply, to look up at the night sky, and to remember, you are stardust. You are part of the cosmos. You are part of the endless, beautiful cycle of life, death, and renewal. Thank you for listening. Thank you for wondering. Until next time, stay curious, stay connected, and always stay cosmic.